Example 1. So a farmer wants to determine whether there's a linear relationship between the mean temperature, so like the average temperature, and during the growing season and the size of his wheat crop. Okay, so he assembles these data for the last 6 crops. So here's the mean temperature, that's going to be our X, and here's the yield, that's going to be our Y. Okay, so first we're going to plot these points on a scatter plot, and we're going to take a look, and we're just going to take a quick guess about whether or not there's a linear correlation. So let's come over here. I'm going to pull up these numbers for myself. So for the mean temperature, let's go, X is going to be mean temp. Let's say degrees Celsius. And then the Y is going to be yield in tons per hectare. Okay, so for the mean temperature, we have to go up to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and up the side, we just have to go up to 2.6. So let's go 0.5, 1, 1.5, 2. Let's go 2.5, and then let's go 3. So if we plot these 4, 1.6, 8, 2.4, 10, 2.0, 9, 2.6, 9, 2.6, 11, 2.1, and 6, 2.2, 6, 2.2. Okay, so just taking a look at this, I mean, we know that as n approaches infinity, so if there were many more data here, that it would be more accurate, but we can only go off of what we have. So taking a look here, I would say that our line of best fit, this looks pretty good, so let's just go right between them. Okay, so our first question is, does the scatter plot indicate a correlation between these two variables? I would say so. I would say that it would be a moderate to strong positive correlation. So that's my guess, moderate to strong, because the numbers are pretty clustered together if you take a look at them. And if you look at our scale is not going up by big numbers. So that means that they're even more clustered. Okay, moderate to strong, positive, because it's going up, correlation. Okay, so that's our guess for A. Now, B asks us to actually calculate the covariance, and then we're going to calculate the correlation coefficient. And we're going to talk about what these mean. So first, if we look back to the formula for covariance, we need X, and then we need X bar, and Y bar. And then for the correlation coefficient, we need basically everything that I gave you in this chart. So what I'm going to put in this last row right here are the totals. So I'm going to put a T here for totals. Okay, mean temperature, I'm going to add 4 plus 8 plus 10 plus 9 plus 11 plus 6. Total is 48. Okay, yield in tons, 1.6, 2.4, 2.0, 2.6, 2.1, and 2.2. 12.9, that's our sum. So I'm going to just use a sum, a symbol. Okay, X times Y. So what we're actually doing is 4 times 1.6. So 4 times 1.6 I get 6.4. And in this one, we're doing 8 times 2.4, just the x value here, times the y value here. And for the rest, I'm not actually going to write that out. I'm just going to actually calculate it. So 19.2, 10 times 2.0, I get 20. 9 times 2.6, I get 23.4. 11 times 2.1, I get 23.1. And then 6 times 2.2, I get 13.2. So if we add all of these up, let's just put the total here. 6.4, 19.2, 20, 23.4, 23.1, 13.2. I get 105.3. Now, for the x squared and the y squared, for the x squared, I would just take the x and square it. So 4 squared, I get 16. 8 squared, I would get 64. Okay, 10 squared, 9 squared, 11 squared, all the way down. So I get 100. I get 81. I believe that's 121 and 36. And if I added all these up, 16, 64, 100, 121, 36, I get 418. Now, same thing for y squared. So 1.6 squared, I get 2.56. 2.4 squared, I get 5.76. 2 squared, I just get 4. 2.6 squared, 6.76. 2.1, I get 4.41. And then 2.2, I get 4.84. If we add all of these up, so I have 2.56 plus 5.75 plus 4 plus 6.76 plus 4.41 plus 4.84, I get a total of 2833. So this is a really long, tedious process, but you need these numbers and you need to show your work. So let's start a new slide. Insert. There we go. Okay, so all I did was copy down the covariance, and then n is 6 because we had 6 data points, and then the sum of the x's, sum of the y's, sum of the xy's, x squareds and y squares. So we were able to do this covariance, and then we'll take a look at the correlation coefficient. So let's go 1 over n minus 1, so 1 over 6 minus 1. And then what we have to do is we have to add up all of the x values minus the x bar values. So, and then y minus y bar. So I'm actually just going to list them here. So first, our x bar, our sum of the x's is 48. So 48 divided by 6, our x bar is 8. Okay, so x bar equals 8, and our y bar, which is 12.9, divided by those 6 data points, 2.15. So what we have to do is every single x value, we have to subtract 8 from it. So we have 4, 8, 10, 9, 11, 6. So we're going to add 4 minus 8, 8 minus 8, 10 minus 8. And I'm listing them because what we're going to have to do is add up all of these. 9 minus 8, 11 minus 8, and 6 minus 8. Now we do the same thing with the y's.